Finally, let's talk about the difference quotient. In the previous video, we discussed the average rate of change between two specific inputs, A and B. Well, what if we wanted to find the average rate of change for a bunch of different inputs all at once? Can we? Of course. The difference quotient helps us determine the average rate of change between an input x and some other number that's a short distance away, normally called h away from x. The formula for this is given by f of x plus h minus f of x divided by h, where this notation means we're taking our function f of x and we're evaluating it at the point x plus h. So if we have an x-axis here, and x is a specific point, then we're going to move some small distance horizontally, and we're going to call that new point x plus h. We're evaluating the function at this point. And we'll notice that if we remember the original formula for the average rate of change, that was f of b minus f of a divided by b minus a. This is actually the exact same formula where a is x and b is x plus h. It's a variable now instead of a number. Let's take a look at what an example of this might look like. Let's remember our formula for the difference quotient. That's f of x plus h minus f of x divided by h. Again, this is going to be a very important formula in Calculus 1, so it's worth learning now. To start, we're going to take our function f of x and we're going to evaluate it at the point x plus h. That means anytime we see an x in this formula, we're going to replace it with x plus h. So what this will look like is f of x plus h. Again, anytime there's an x, we're going to replace it with x plus h, and we're going to leave the rest as is. If we want, we can directly plug this into our difference quotient formula here. So that will be 3 times x plus h plus 1 minus f of x. We're going to subtract the entire original function. And since we're subtracting the whole thing, I'm going to put it in parentheses to make sure that we're actually subtracting each part of it. And then we divide by h. At this point, we've plugged everything in, but now we need to simplify. So let's go ahead and multiply through these parentheses. This is 3x plus 3h plus 1, and then we can distribute that minus sign as well, minus 3x minus 1 all over h. Now, anytime we do a problem like this, we'll notice a whole bunch of things cancel. In this case, 3x and minus 3x, plus 1 and minus 1. And in this case, we're left with 3h divided by h. Those simplify too, and we're left with just 3. Remember, we didn't actually need to do this math to conclude that the answer would be 3, because we know that this is a linear function, and therefore its rate of change, no matter what inputs we plug in, is always going to be 3. So that's one way you can check your work whenever you're finding the difference quotient for a linear function. The answer should just be the slope. For quadratic and other more complicated functions, it's not quite as simple. So let's practice. Same idea, we're finding the difference quotient f of x plus h minus f of x divided by h. This time our function is a little more complicated. G of x is a quadratic function, x squared minus 3x plus 1. We're going to start by doing the same thing, evaluating this function at the point x plus h. Once again, anytime we see an x, we're going to write in x plus h. So instead of 3x, we're going to have 3 times x plus h plus 1. And then let's go ahead and plug this in to our difference quotient. In this case, f of x plus h, or I suppose more accurately, g of x plus h, that's going to be, as we said, x plus h squared minus 3x plus h plus 1. Now we're going to subtract g of x. and we're going to subtract the entire thing, so we'll put it in parentheses, x squared minus 3x plus 1, all divided by h. Just like before, we are going to expand and simplify, and hopefully a lot of this is going to cancel. Let's see what we get. If we remember FOIL, x plus h squared becomes x squared plus 2xh plus h squared. Then we have minus 3x minus 3h plus 1. And then we'll subtract x squared. Minus minus means plus 3x, and subtract 1. This is a bit of a mess at this point, but let's see what cancels. We've got an x squared and a minus x squared. We've got a minus 3x and a plus 3x. We've got a plus 1 and a minus 1. And if we do all our math properly, we should notice that the only terms remaining all have an h in them. Specifically, we've got 2xh plus h squared minus 3h all over h. And since everything has an h in it, let's go ahead and factor out an h. That's 2x plus h minus 3 all over h still, because we're multiplying and dividing by the same thing. These cancel, and we're left with a final answer, 2x minus 3 plus h, if I rewrite it just a bit. In Calc 1, you'll learn a much quicker way to calculate this and why this formula is actually very important. So hopefully you go on to take that class. It's a good course.